Hello! Hello, everyone. Welcome to the LIUniverse. I'm Dr. Charles Liu, your host, and I would be overjoyed if you guys would all refer to me as Chuck. It's a wonderful day today. We're having a great time, and I'm, as always, thrilled to introduce my co host, Allen Liu. Hey, Alan, how's it going?
Hey, how's it going with you? I never
Uh,
ask you, you always ask me.
I'm doing very well, thank you. I'm having a lot of fun. Today, I'm so psyched to have two amazing guests. I would call them a dynamic duo of physics. They have amazing stories to tell. They have so much to contribute to us. Dr. Betty Jensen and Dr. Mary Lou West. Hello to the two of you. Hi. I wanted to tell everybody just a little bit that Dr. Jensen and Dr. West both were at Columbia in the PhD program, physics and astrophysics, respectively. In the 1970s is when they got their PhDs, and they've gone on to impressive careers in physics and industry and academia and teaching. And I really can't wait to talk to them and learn all kinds of cool stuff from them because it's such a rare opportunity to be able to speak to giants like this. It's marvelous because I have such a good time speaking with both of you individually, but the two of you have so much in common, and together you can tell stories about things that we all are interested in, super relevant today, and all the fun connections that we have as scientists and as human beings with the past and the future. So thank you for being here, and I really am glad that we can chit chat and just have a good time in a moment. Thank you, Mary Lou and Betty, for being here today. Okay, it is time for today's joyfully cosmic cool thing of the day.
It's a joyfully cool cosmic thing.
Oh, the joyfully cool cosmic thing of the day.
It's
Yes.
the
Well,
recurring segment.
it is the thing that we do all the time, and it has to do with Jupiter's great red spot. Now, Alan,
Mhm.
and Betty, maybe you learned this as well long ago, that the great red spot is a blob on Jupiter. It's an atmospheric storm, an anticyclone that's been going on for centuries,
Mhm.
right? Now, Mary Lou, of course, you've taught that, uh, uh, but I did not know until just this past month that researchers have shown that the Great Red Spot has not been continuously in existence from the time it was first discovered in the 1600s to the present day. In fact, current research done by a group of Spanish astrophysicists slash meteorologists, planetary weather specialists, really, they seem to have shown conclusively using computer simulations and historical observations that what we know today as the Great Red Spot is actually the second of two big giant spots. Cassini, the first guy who reported this, saw stuff in the 1600s, and that spot was viewed until about 1710, 1715 or so. And then nobody mentioned it for more than 100 years until it was seen again in the 1800s. Well, now
Mm.
observations seem to show, and these calculations, that the Great Red Spot is indeed only 190 years old, as
Only.
opposed to more than 400 years old. Right. I mean, only, right. We're freaked out if a storm lasts 190 hours here on Earth,
Yeah,
but
fair.
190 years is still a tiny amount, which is, I think, amazing that we're able to actually figure stuff out from past data and present and future observations and computer simulations. And that computer stuff is where we're talking about right now. I don't know, Alan, if you have any thoughts about a 190-year-old storm as opposed to a 400-year-old storm.
Yeah, I mean, so what I'm wondering, I guess, so the what the paper is citing is that there were people who were looking at Jupiter, like Messier and so forth, in that
Hmm.
gap, and they didn't talk about there being a great red spot. I'm wondering if it's possible that maybe it didn't just disappear and then reform, because they don't. No one talks about a smaller red spot growing or merging to become this new great red spot.
It's
So
true.
maybe it just changed color and it was less harder to see against the background, or maybe something like that also could have been possible at the same
Yeah.
time.
Mary Lou, as the astrophysicist in this room, what's your take?
So one of the things I thought was interesting about this Spanish paper is that Cassini and the people who saw it early on in the 1600s never referred to it as red. They referred to it as a dark spot, the
Oh,
dark
Hmm.
permanent spot, or just the permanent spot, or just the dark spot. And then when it came back and when it was seen in the 1800s, people immediately started talking about the red spot. So I think that's
Interesting.
interesting that the color change seems to be historically recorded. So,
Mhm.
so it's
Wow.
200 rather than 400 years old. Nonetheless,
Still,
we
It's
don't want storms that last anywhere long, anywhere at all.
yeah.
So that's the reason you
still
don't want
pretty
to.
old.
The reason you don't want to go to live on Jupiter is not the gravity; it's the storms.
Hey.
Yeah.
Would it just be that because Jupiter's atmosphere is so much bigger, the storms don't bump into each other and knock each other out all the time? Is that why this can last 200 years?
No, I don't. Nobody knows, but the storms do bump into each other, and some of the smaller ones do merge. So there's
Mhm.
lots of storms on Jupiter. There's the great big one, and then all these little ones, and they pass around the big one, or
Hmm.
the different band entirely. Sometimes they merge. Very rarely do they destroy each other. So I don't think somehow the merging is the problem. But there must be a
Mm,
huge amount of momentum going around in this thing
Yeah.
because
marvelous.
when at its biggest extent, it is shrinking a little bit now. The Great Red Spot could hold 3 whole Earths across it. I mean, that's just so
Dang.
scary.
That is.
Yeah, we don't want to get caught in anything like that.
No,
Uh,
no.
Now, Betty, your expertise in physics was not astrophysics, but it was something equally cool, in my opinion. Tell us about it and your whole process and how you got to the place you are today professionally.
Well, my thesis was in plasma physics, basically trying to get fusion energy going. And
Yes.
we're still waiting.
We are still working on that one.
Yeah. I, when I was starting graduate school, that was the 70s, and energy was the big thing.
Mm.
So, and fusion was just 30 years away.
Now it's been 50 years.
So that was my thesis.
Wow.
And
And you had gotten to Columbia after a distinguished career, but not majoring in physics, right? You had a different major as an undergraduate. Is that
as an
correct?
undergraduate, no, I had physics and math.
Oh,
Technically, I had both because,
fantastic.
well, to get a physics degree, you have to do enough math, so you get a double major.
Ah, so
Very.
that's how it worked out.
Makes sense.
But you chose physics as a PhD as opposed to the math because physics is cooler?
I was always going to be a physicist.
Ah.
You're going to laugh at this one, but even in high school, I graduated high school in 3.5 years, so I couldn't take. They generally offered chemistry in the junior year and physics in the senior year, but
Mm.
I wanted to be a physicist. So they had to give me a special program, and I took physics in my junior year. I was the only one there.
Wow.
And then I took half a year of chemistry before I graduated high
Impressive.
school. So I knew I was going to be a physicist.
Well, Alan, I'm afraid it's score one for the physicist and not the mathematics. You went the other
And
direction, of
yeah.
course, but that's okay.
Yeah, I studied the math primarily, yep. But I
Mhm.
took some good physics classes in there as well.
You most certainly did. And so, did the nuclear fusion stuff eventually shape what you wound up doing, Betty, in your career?
Well, that's an interesting question. What I wanted to do was to teach. And
Mm.
when I came out, I was restricted to the New York area because my husband was working already at that time. But we had selected New York because of greatest opportunities for both of us.
Ah.
And he was working, so I was restricted. And there were no teaching jobs around
Ah.
that time. If you know, the 70s were a tough job market time.
Oh, yes.
And
Much worse than it is today. Mhm.
I got a job at an electric utility,
Ah.
and it was great. At first, I managed nuclear research, which included both fusion and fission.
Aha.
And the interesting thing is they had an R&D department, which I don't think they have any longer.
Hmm.
But I was involved with the Electric Power Research Institute, with the Department of Energy, with a whole lot of national and international committees. So while I wasn't necessarily doing the research myself, in many cases we were funding research. I know
Ah.
I was on an advisory panel to Princeton, MIT,
Wow.
NJIT, whatever that,
Mhm.
New Jersey Institute of Technology. I was on many of these committees because we were funding things,
Mhm.
and
Marvelous.
you get to be an advisor to
Yeah,
supervise some of the monies that you give out.
I think that's great. Now, Mary Lou, you had a similar story why you stayed in the New York metropolitan area. It also had to do with family, right? What we scientists often call the two-body problem. Tell us about that a little bit.
Yeah, so my two body problem was my husband is a chemical engineer, and so he worked for Exxon Research and Development here in New Jersey, in Linden. And so we were constrained to be in the northern New Jersey area. So Columbia was a natural choice for me to go to graduate school. But I want to tell
Mm.
you something. I also, Betty, was a major in both mathematics and physics.
Ooh.
I became a mathematics major at first undergraduate because um, my mother said that women were not suitable to be scientists. So
Mm.
Ah.
I was mathematics, and I enjoy mathematics and I really like it. Um, but in my sophomore year at Cornell, I went to a professor for his office hours to ask a question about the homework. Um, and I asked him, this particular abstruse kind of mathematics, what is it ever going to be used for? And he said, well, we don't know, but you can't ask that question. And I said, yeah, I'd like to ask that question.
Yeah.
What do you think this might ever be useful for? And he said, ask that question. He says, you are going to be a physics major, and you go out this door, you go across the quad, you go to Rockefeller, you sign up to be a physics major, and then come back and tell me about it. So I did. So I was a
Wow.
double major in physics and mathematics, and I enjoyed both of them. And then, so then the next question, well, how did I become an astrophysicist? Well, in my senior year as an undergraduate, I took one course that was an elective, and that was the magnetohydrodynamics of the solar system. So it
Ooh.
involves, it's so cool. So it involved the solar wind and the tails of comets and things like that. How we knew that there was really plasma out there. Plasma is very cool, Betty. I think you're absolutely right on that one. Uh, this was really cool. So I applied to graduate schools in astrophysics only, not math or physics, and
Mm.
got accepted to Columbia. And so that's where we went, New York City.
Wow, that's fantastic. I love that.
Amazing.
And one thing in common, of course, with nuclear plasma stuff and astro is that in the same way, Betty, that nuclear fusion power is only 30 years away, always 30 years away, right? Mary Lou, human life going onto Mars is also always 30 years away. Human, we'll just get there. We'll get there
Maybe if
soon
we wait
enough.
30 years, it'll be 29 years away. Who knows?
Oh, that would
We
be
might be
nice.
making progress.
Yeah, I should add that after a few years, probably 10 or so, I went over to the environmental area.
Oh,
Oh, I
cool.
see.
Physicists, there's physics, as you obviously know, in
Mhm.
transport, in obviously some chemistry in the emissions of various gases and so on. But
Sure.
the transport is very much physics oriented.
Yeah.
And I even got involved with health effects. I was involved with study of health effects of electromagnetic waves, health
Oh,
Ah.
wow.
effects of, I was working with very interesting people. There were health effects of various pollutants, and I
Mhm.
learned a lot. The point is,
Yeah,
if you have some basic skills, you can apply them to other fields as well.
I
That's great.
agree. And
So,
still very relevant today. It's still modern.
so for anybody getting out of school, at the age of 22 or 25,
Mhm.
you're not committed for life to whatever skill you were involved with.
That's good to know.
We're going to take a short break here on the LIUniverse, and we'll be right back right after this. And we're back here on the LIUniverse. Okay, well, let's ask some questions. We have questions for these distinguished Dr. Jensen and the distinguished Dr. West. Is that not right, Alan?
We do have questions. We got a few here. Our first question that we're going to ask regards sort of well, actually, all of these questions that we are planning to ask sort of regard your educational experience and sort of how that's affected your life in general. This particular one is asking what kinds of mentoring opportunities were available during your PhD years?
I felt as the lone woman in the area, not very supported.
Hmm.
Okay, I can admit to that. But we had some really good experiences in general, with professors. Uh, I think all the students, or I particularly loved Professor Robbie.
Hmm.
Was We used to have colloquiums every Friday at 3 p.m. And us graduate students really didn't understand most of the colloquium presentations anyway. But some of the younger faculty members used to constantly get up and berate the speaker, accusing him of getting something wrong.
Oh my
Hmm.
goodness.
But Robbie, always the gentleman, he'd raise his hand and we'd all chuckle because he'd say, "I'm sorry, I didn't understand whatever. Can you please go over it again?" I mean, it was such a gentle way of addressing the speakers. We were
Oh,
really, really impressed with that.
that is so cool about Dr. Rabi. Now, for those of you who don't know this person, Dr. Isidore Isaac Rabi, a Nobel Prize recipient in physics, one of the real great pioneers and apparently great gentlemen of 20th century physics. Mary Lou, did you know Rabi? And did you have, say, a mentoring experience that was positive or negative or interesting, anything like that?
All right, so I knew Robbie only a little bit, and I'll tell you a story I heard about him, but I had a different person who mentored me. At any rate, while I was there, a journalist came and interviewed Dr. Robbie and asked, "Why did you become a physicist in the first place?" And he said, "Well, it all had to do with my mother. She wasn't like other mothers when I was in grade school who would ask when the kid came home from school, 'What did you learn today?' No, no. My mother always said, 'Did you ask a good question today?' And so I had to become a
Hmm.
Hmm.
physicist."
I like that very much. Well, Robbie was very much involved in magnetic resonance imaging. So if you've ever had an MRI or an
Mhm.
NMR of anything like that, you have Robbie to thank, which is really quite amazing. And he certainly asked the right questions for that. Now, what was your take, Mary Lou, on your mentoring experience with those other people?
All right, so um, I had to do two PhD theses
Oh, no.
Oh,
because
interesting.
the first mentor I had, the first PhD advisor was Ludwig Volcher, who is very good,
Hmm.
and I'm really interested in magnetism and current flow and that sort of thing in plasmas. So I was doing a thesis on the magnetic environments of spiral galaxies, and that was coming along pretty well until somebody published the same sort of thing in Europe, and
Oh,
Oh.
Dr. Volt did not know about this. So clearly, I couldn't do the
oh,
same thing, so I had to start over again. So he said, "You know what?
wow.
Instead of starting over with the galaxies and the magnetism, why don't you go work for this other professor over here who just had somebody leave and is doing computer simulations of the velocity flow of stars in galaxies?" And I thought, well, okay, I'll do that. And he was not a very good mentor. Um, and
Hmm.
it made it difficult, but eventually I did finish and got the PhD uh, from that. But I had an interesting
Wow.
experience with the thesis defense. This is a funny story. So um, I had my thesis defense in 1970, and it
Hmm.
turned
Okay.
out to be just after the shooting of students at Kent State in Ohio,
Oh, my.
Hmm.
having to do with war protests. Well, Columbia had already had student riots and protests in 1968, so 1970 was going to be the same
Yes.
thing, they figured, and there would be student protests and all sorts of clashes with the police, and it would not be a good thing at all. So they closed the university.
Oh, wow.
So I got to the entrance to Columbia that day, and these five professors who came to be on the committee got there too. And it had been very difficult for us to find a date when all of us could get together, and this was the day. But the police would not let us into the university. So, what to do? So, instead of trying to reschedule this thing, um, we decided to go to the apartment of one of the people in the group who lived only a couple of blocks away. So we all trotted down the street and went to his apartment. And this is before cell phones. So we opened the door and he says, "Hi, guess what? We're having 5 people and we're going to have a meeting at the dining room table. You have to clear the dining room table right now." And so she did. I'm looking very surprised at all this. At any rate, we sat around the dining room table, and the PhD candidate gets 20 minutes to give her story about what the thesis is all about, and then they ask the questions. So I was starting to do that, and they kept saying, "Could you write that down? I didn't understand that very well." And so I said, "Yeah, I really wish I had a blackboard, but let me just say again what I just said." And then one of them said, "Oh my God, she needs a blackboard." And he ran out of the room, ran down the hall, clump, 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 slam, slam, clump, 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 comes back. And he had gone to a neighbor's apartment and gotten a cute little blackboard that was for a child. So it was the alphabet and the numbers across the bottom. It was probably, I don't know, 18 inches by a foot big. And I had one little piece of chalk. But I did manage to write on the blackboard elliptic equations of the second kind and explain what they did and why they were necessary in this particular computer thing. So that left the room for a while, and eventually I passed. So that was a good thing. But the strangest little blackboard I've ever used.
That's amazing. The most exciting day in that blackboard's history as well.
Yeah, right. Who knew? Elliptic curves of the second kind. How about that on a children's chalkboard? Now, I'm just bummed that that professor informed the other member of the household that that person had to clear off the dining room table. The professor should have gone in and helped clean the dining room table with himself. But that's a different story. Betty, I'll bet you your dissertation defense was not quite as exciting as this, but you probably went through some pretty exciting times yourself at Columbia. I mean, that place, even today, right? Big hotbed of student activity, protests, and so forth. You were probably caught in some of that.
Yep. We were caught in 1972. There was a student demonstration against some of the professors were involved with Jensen, which was helping the Department of Defense. And at one point, we heard that the students were going to take over the building and probably possibly destroy property. So the faculty and the graduate students spend the night sitting on the floor in the hallway, protecting the building. And nothing happened, but it was kind of fun. And you got to know the professors on a personal level, which you probably wouldn't have gotten to otherwise. So
amazing.
It was a good experience from my point of view, at least.
Yeah, I think it's a good thing to spend exciting, tense evenings with your faculty in shared activity, as opposed to one side being tense, like in a defense, and then the other side just kind of relaxed and calmly trying to interrogate you. So that sounds like fun. What did you learn about physics faculty on that day? Are we all weird? Are we all? Just tell us how were those faculty back in 1972?
They were all men.
Oh,
and
right.
Very few women, even among the students.
Yeah.
Oh, right.
You know, so I know during my entire experience at Columbia, I don't know about you, Mary Lou, but I was very conscious of the fact, and the same thing in undergrad, of being the sole woman.
Wow.
And afterwards, even when I started the business world, that was something that permeated all situations.
Yes, there was a lot of that, and there were assumptions being made all the time of what your function must be. And I remember one year we had a new graduate student who came in and came to the graduate student office where we had like six desks set up around there, and you put your stuff there. And he walked up to me and said, "Well, since you're the secretary, I want you to type this for me right away."
Oh no!
Oh,
my goodness! No, I'm not doing that. I'm another graduate student, not the secretary. And he went, "Oh, humph." And then the next day he came and had some other demand for me, and I said, "No, don't do that either." Uh, and
Oh
eventually,
man.
this guy
Oh
was a
my goodness.
pain, and
Yeah.
did this several different times. And then the weather got cold, and he wore snow pants on the outside of his regular pants and rode his bicycle to the
Hmm.
building in the morning. So the second day he did that, as soon as he left the office, I took my thread and needle and I sewed his pants shut at the bottom. So when he left that night, he couldn't get his feet through, and was very upset. But I already left, so that's the way it went. So
Wonderful. I love that. I hope that person learned a valuable lesson that day. Now, probably the most famous
he
or best
he, uh,
known. Uh,
he failed the qualifier and he left. So there you go.
oh, well, that solves the
Ah,
problem. Now, probably the most famous woman physics professor back in that part of the 20th century was Madame Wu, right? Wu Jianxiong, whose Wu experiment proved that parity was not conserved in subatomic systems, and it was amazing.
yeah.
Now, of course,
In
unfortunately, right? I don't want to get too technical about the physics stuff, just that she was an amazing
yeah, parity
experimentalist.
conservation is the idea that the universe looks the same if you flip everything left and right and vice versa.
Mhm.
For the people who might not know the terminology. And
Yes, thank you,
her
Alan.
experiment showed that that's actually not true about everything in physics that we see in the world. There are some physical things, like involving radioactive decay, that actually it matters whether you're looking at it in a mirror or not in a mirror.
That's right. And of course, as you might unfortunately expect, she did the experiment with her graduate students, including one of whom was named Marion Biavati. And Marion and she did not get awarded a Nobel Prize, but the physicist men who predicted the results of her experiment
Mm-hmm.
were awarded the Nobel Prize in physics for that very same thing.
Yeah.
And that remains one of those things in life. But obviously, when you have something like a Nobel Prize or any prize really that's selected by people, sometimes these things happen. But you two both intersected with Dr. Wu, right? Betty, did you ever take a class with her? Did
I
you?
took one class with her,
Uh huh.
and I don't remember that many details about her, but I do remember that she talked to us about Fermi's reaction on the day the bomb was dropped.
Oh my
Yeah.
gosh.
Apparently, the entire team was shocked that he didn't say a word afterwards. They were
Wow.
all expecting him to talk about it,
Hmm.
and he never said anything.
Wow.
Was this on the day that the test happened, or just on when
The Trinity
or
explosion,
was
right?
this during
The
the
explosion.
bombings that
Yeah, because
or the
remember, yeah,
attacks?
Yeah,
no, Madame Wu was in the Manhattan Project.
correct.
So those stories, like in the movies, oh, I don't know, Oppenheimer that you see,
Mhm.
I
Yeah.
don't know if they showed accurately that Madame Wu was there. Uh, but Fermi said nothing.
Yeah.
Since we're talking about famous people,
Yeah,
once I was working already, I attended a meeting where Teller gave a presentation at
tell
Oh
her.
Princeton.
wow.
Wow, the father of the H bomb. Amazing.
And after the presentation, my husband and I drove him back to the airport, to Newark
Ah,
Airport. And I was sitting in the back with Teller, and the entire time he was talking about the fact that a student asked him a question after his presentation, and he was concerned that he was too abrupt with his answer.
oh,
I wouldn't have thought that he'd cared that much, but that seemed to really disturb him,
Hmm.
that
wow.
he cut off the student. So I don't know how he's portrayed elsewhere, but he certainly had a real nice personal concern for the students.
Wow, that's very lovely.
Oh,
That's
wow.
good to hear. Mary Lou, how about you? Madame Wu, other people? Cool story?
So I did not know Madame Wu, other than to see her passing in the hallways, because by that time I was in astronomy and she was in physics.
Hmm.
Um,
Okay.
so not so much at all. Um, I thought it'd be interesting to tell people though about the Harriman Observatory.
Yes, tell us about this Harriman Observatory thing. I presume it's upstate New York in the Harriman area.
Yes, so in the late 1960s, the astronomy department at Columbia University decided to build an observatory and put a telescope in it at the estate that Columbia University owned at Harriman, New York, up on the Thruway. So they built a building, a small building, and had the dome ready, and they opened the dome and then had the telescope, which was a huge 500-pound cannon on a flatbed truck, and they brought it up, and the crane would pick up the telescope, extend the boom, and drop it in through the slit, and place it on the pier, which was waiting for it inside the building. Well, all the graduate students were sitting on a rock nearby watching this whole thing, and we were horrified that when the crane picked up the telescope and extended the boom, it was too heavy, and the back wheels of the crane came up.
Ah!
So it was going to tip over, fall into the building.
Bam!
The crane operator was very, very quick, retracted the beam, put the thing back on the truck, went out, unattached it, and drove away. And then a week later, they got a bigger crane to fix it up. So that was a little too exciting.
At least there was quick action that prevented a complete disaster.
That's true. Wow. Now, Betty, did you have excitement with equipment at one point in your graduate career too?
I was a theorist. So
Paper and pencil were much less dangerous, right?
computers.
So I can't finish our conversation without asking you guys about those punch cards. Okay, because I just love the thought of doing computer stuff that back in the day was state of the art. And nowadays we look at it and go, wow, things move out really, really fast. But both of you did a lot of computer work back in the 70s with punch cards, with things like that, right? So Betty, tell us a little bit about some of that experience and how that carries forward to modern times, the things that you're doing now, or how you think about those times in the past.
Well, much of my dissertation was done using the punch cards. And I think I probably still have a box of my cards in the attic. Or
Oh, nice.
I haven't been up there in a long time, so it's probably still there. The funny thing is, my daughter, when she was in I guess 5th or 6th grade, had to write a paper on the history of computers. So I gave her some punch cards because I use those as bookmarks. So I have them in an old cookbook that I have still from the 70s. There's still some punch cards sitting in there. And he was so impressed, he couldn't believe it. He asked me, "Where did you get one?" If you look at some of my old books, you still find them.
That's amazing.
And Mary Lou, you too, right? Doing all that magneto-hydrodynamic stuff on the computer?
Right. So my thesis was about 500 punch cards in a box. And you just lived in great fear that on your way to the computer center where you had to give them in and then go back 24 hours later and get them back, you had this great fear that you would trip and fall and they'd have to pick up all the cards and reorder them in very specific order. That never happened, right?
Oh, no.
But then I have another story. So in the mid-70s, I had children and worked in England for 2 years. And at that point, I wanted to have the youngest, who was just 1 year old, entertained while I got to talk to a professor colleague there. So we would sit her down at the punch card machine, and we'd take 10 punch cards and put them in the input, and then she would just type away like crazy, and the thing would shoot across and end up at the end. Then we'd take all 10 of them, put them back in the input again, and let her punch again. And the idea was she would take about a half an hour to make complete lace out of these 10 cards. But at that point, I confer with this professor I was working with and get something done. So one of her first words was pewter. She couldn't say computer, but she said pewter. Because after she worked at the pewter for a while, she got a cookie. So that was the good thing.
That's amazing.
I love that. Now, both of you have talked about your children. Did their upbringing uh, reflect your educations and your careers to the extent that what they're doing today is something scientific or otherwise related to physics or anything like that? Mary Lou?
So I have two children. They're both engineers. One's a mechanical engineer. The other's a um, chemical engineer. They both use computers quite a lot, and yeah, they're very scientific, and also very musical. So I'm musical as well, and so
Nice.
we,
Wow.
we have a lot of stuff that passes on. Yeah.
Fantastic. And Betty?
My husband was a mechanical engineer, and
Mhm.
I'm obviously a physicist. Our children did not go into the sciences. Uh, but the interesting thing is, I have three of them who went to law school. One of them is in finance.
Hmm.
But the interesting thing is that one of the lawyers, when he was in middle school, he had a computer teacher who told him someday he's going to be a computer expert. And
Oh,
after he got his law degree, he's not practicing. He practiced law for about a year or two and decided he didn't like it, and now he's into computers.
well,
Amazing.
there you have it.
Anything,
Wow.
any overlap? Computer law is a big issue, I know, with cybersecurity and everything.
All I know is if I have an IT problem, that's who I call.
Yeah,
That's awesome.
yeah. I get that too. I'm like, Alan, none of this works. Help.
Yeah, it helps to be able to troubleshoot your
Yes,
setup here.
and your mother and I are grateful, Alan. Thank you.
Ah, great.
That's always the case. Well, the time has flown by. I wish we could continue conversation. I hope we will be able to talk more, but let's finish by a question I wanted to ask both of you, each of you, please. Do you, now having had rich careers after higher education in science and physics and astrophysics especially, do you have something that you'd like to tell our audience uh, that you want us to know? Something that, I know there are probably many things that we would all benefit from hearing from you, but is there something that you would like to say at this time that we should all kind of know and be aware of? It can be anything. Just give us a thing. Mary Lou, tell us.
So it's the old thing. I think um, do what you like. Find something you really really enjoy, and do that as a job if you can. You'll never work a day in your life. And I really really enjoy astronomy and astrophysics, and it's just the most wonderful thing. Every day something changes. Astronomy doesn't stick still. It keeps on changing, and it's so exciting.
That is awesome.
Wow. Thank you. Great thing to think about. Betty, do you have something for us?
As I tell my students when I start the year, physics is the foundational science and it explains everything, including stuff that we don't know how to explain yet. But it's the foundational science. And I know I was just reading a book that has to do with biology and medicine, the one cell, and it's full of physicists that moved over into that field to apply their physics into biology.
That's really
So
cool.
if you
Yeah,
learn the proper skills, you can apply them everywhere.
That's really great.
wonderful news. Um, we will do this again sometime, I hope. Okay, Betty and Mary Lou, thank you so much. But this has been so much fun to chat, and we will do this again. Dr. Betty Jensen, Dr. Mary Lou West, thank you for being guests with us today. Thank you so much.
Thank you.
Thank you.
Alan, as always, Allen Liu, our co host, thank you so much for being here.
Yeah, happy to be here.
And for all of you in the audience, thank you so much for being with us today. If you liked what you've seen and heard, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.